Welcome to Unit 8, Lines and Planes, Lesson 1, Equation of a Line in 2 space and 3 space. We're going to review a bit from grade 9 math, and then we're going to move it into calculus and vectors. So here we go, review of linear equations. Of course, we've seen this before. We've seen this equation, y equals mx plus b, called slope-y-intercept form, and we've actually seen this one a lot in calculus, and we also see standard form. We haven't seen this so much in calculus, we've seen this definitely in grade 9 and grade 10 math. With graphing lines and using it to use substitution elimination to solve linear systems. All right, the first thing says, investigation, the line negative x plus 2y minus 10 equals 0 illustrated to the right. So here's the line right here. Rearrange the equation to slope-y-intercept form, so I want to isolate for the y, so I get 2y is equal to x plus 10, divide everything by 2y equals 1/2 x plus 5. How many vectors exist that are parallel to this line? Well, there are infinite. I could have that vector there, that vector there, that tiny vector there. So these are all vectors that are parallel to the line. So infinite. Now I want to draw the vector negative 1, 2. Where did those numbers come from? We'll see in a second, but here is the vector negative 1, 2. There it is, right over there. Now, again, where do these numbers come from? If I look here, negative 1, 2, I look at my given equation, this guy here, I can see negative 1 would be my A value, and 2 is my B value. So that's where I got it from. And the next question says that, so draw it, and then step 3, or then it says here, sorry, still step 2, compare the vector with the equation line and with the graph of the line. What do you notice? Well, if I move this guy around a bit, so I move this guy, if I look at those, I can see that that vector and that line are actually perpendicular to each other. So the vector and line are perpendicular. Now maybe that's just a coincidence. Let's try another one. So here's another one. It says on the blank graph here, graph this equation by using x and y intercept form. So to find the x-intercept, we set y equal to 0 and solve. So I have 3x equals 12, x equals 4. So on the line here, I'm going to put a pointer there. X equals 0, so this is my y-intercept. So I'm going to put 3 times 0 plus 4y minus 12 equals 0. So here I get, bring the 12 over, divide by 4, I get y is equal to 3, so I have a point right here. Once I get these 2 points, I can then draw my line. I'm going to cheat a little bit. Whoops, didn't mean to do that. A little step ahead of myself, but there's my line, that red line there. Now next says draw the vector 3, 4. Already done that. There's my blue line. Compare the vector and the line. What do you notice? Guess what? They are perpendicular again. The vector and line are perpendicular. All right. That says line, by the way. My terrible writing. All right. Describe how your answers to step 2 and step 4 are familiar. Well, guess what? Both answers are the same. The vector and the line are perpendicular. Give an example of different line and a vector pair that have the same property as those in step 2 and 4. So what can I write here? We know, general form, the vector AB is perpendicular to the line. Whoops, didn't mean to do that. To the line AX plus BY plus C equals 0. Example, the vector 3, negative 4 is perpendicular to 3x minus 4y minus 24 equals 0. Don't believe me, try it, and you will see that yes, this vector here is perpendicular to this line here. All right, so that's our first really know how. We're gonna formalize it at the end. So here we go. Equation of line in 2 space. We're gonna go through some definitions here. Standard form, we call this the scalar equation of the line or the Cartesian equation. We've seen this many times. This is new though. Point of interest now, this is new to calculus vectors. AB is the vector normal, and again, normal, what does that mean? That just means that it is perpendicular to the line. So for instance, negative x plus 2y minus 10. So this is perpendicular to vector negative 1 to just the a and the b value. Slope y-intercept form, points of interest here. M is the slope, and b is the y-intercept. This was talked a lot about in grade 9 math, and again we talked about it up in calculus. So this guy here, that is my slope. And this guy here, that is my y-intercept. All right. Nothing new here. Let's continue. Vector equation. All right. You might want to pause the video because I'm going to go through these definitions. I'm going to talk about them. If you want to write them down, again, they're on the website, or you can pause the video and just write them down. So here we go. Vector equation of line. R is equal to R naught plus T vector M, or this is one we're really going to look at. These are the exact same, just written out. So R is actually equal to XY, R naught is equal to X naught, Y naught, and M is equal to M1, M2. But what do they mean here? So vector form of line, so here's an example. What is T? T is a scalar, and it's any real number used to calculate all points on the line. So it can be, again, any real number, but it is a scalar. R, what is R? R is a position vector to any known point on the line, and it's written like this. Oops. It's written as x, y, position vector xy. All right, so R is a position vector to any unknown. Now I really should say unknown or known. What you mean? Well, we'll see that in a second. Really unknown or known point on the line. And it's written as that. All right, next one is this. It says R naught. All right, R naught is X naught, Y naught. Could say a joke here, but I'm not going to. A position vector to be any known point on the line. So to give you an example, here is my line, and if I drew X naught, there it is, X naught. So you can see I've got a position vector to a known point on the line. My known point on the line is right here, 2, 6, and you can see it's right here. So it is a position vector to any known point on the line. All right, and vector M. Vector M is actually the xy coordinates of the slope of the line. Is M1, M2, and I'm going to draw vector M here. Cheat a little bit, but there it is right there. So that's vector M. You can see 2, 1. And if you look here, if you drag this vector here, you can see that it is parallel to the line. So that position vector is always parallel to the line. Whoops. There we go. All right. So that's that. Again, if you want to spend a little bit of time, you can write that down, but I'm going to move on from here. All right. Vector form of the equation. So we've talked about this one already. Parametric form of the equation. It is actually looking like this. L. So it's basically this vector form written kind of in rows. So x is equal to x naught plus t m1. So it's really taken from this guy here, and y is equal to y naught plus t m2. Parametric form here. So if here's my vector form, so you can see t. So if my x would be equal to 2 plus 2t, which is right here. Y is equal to 6 plus 1t, or just t. Parametric form and vector form are very, very similar. In fact, they are the same thing, just written a little bit differently. All right. Let's do some examples. Here we go. So it says write a vector equation up for the line through the points A and B. So what do we do here? Well, first of all, we need R naught. And our R naught is any known point on a line. So my R naught, I can use either A or B. I'm going to use A, but if you want to use B, that's okay as well. So there's my R naught. It's a position vector to any known point on the line. I could use 1, 4, or I could use 3, 1. Now, M is actually going to be the position vector AB. Why? Because AB would be a line that's parallel, would be a position vector that's parallel to the line that goes through these 2 points. So my m will be here, 3 minus 1, and 1 minus 4. So my m would then be 2, negative 3. So what is my vector equation? Running out of room here, I'll write my vector equation here. My vector equation is xy is equal to 1, 4 plus t 2, negative 3. And there we go. Done. It says here, determine 3 more position vectors to the point on a line, graph the line. So here, for instance, I could choose, what I'm going to do here is choose any value that I want for t. So just choose any values for t. Let's do an easy one. Let's do t is equal to 1. So then I'm going to have xy is equal to 1, 4 plus 1, 2, negative 3. So that's really going to be equal to 1, 4 plus 2, negative 3. And I just add up the coordinates. This is going to be 1 plus 2 is 3. Next one's going to be 4 plus negative 3 is 1. So I've got the point 3, 1 right there. I'll put that there. All right, next one, this is, so I'm going to do t equals 2. So I'm going to have here xy is equal to 1, 4 plus 2, 2, negative 3. I'm going to skip a few steps here if you don't mind. So it's going to be 1 plus 2 times 2. So it's going to be 5. 4 plus 2 times a negative 3. So it's going to be negative 2. So 5, negative 2, right down there. And let's do t is equal to 3. So I'm going to have xy is equal to 1, 4 plus 3 times 2, negative 3. I'm going to run out of room here, so I'm going to write it here. So it's going to be 1 plus 3 times 2, that's 7. And then 4 plus 3 times negative 3, so that's going to be negative 5. So 7, negative 5, which is right down here. And then I'm going to draw a line through those. So let me just do that. See if I can do this correctly. There we go. Oop, I have to fix that a little bit. I'm going to get rid of this guy. And I'm just going to just move this guy so it goes through those 3 points. And there we go. Oh, almost good. There we go. And there's my line. The vector 2, negative 3, if I were to graph it, position vector, you see it's parallel to that line. And the point 1, 4 is on my line. My line's not perfect, but there it is. Next question says this, determine if the point 2, 3 is on the line. Well, first of all, I can see that 2, 3 looks like it might be close, but let's check it out. So we're going to actually do this algebraically. How do you do it algebraically? Well, this will become my x, y. So I'm really going to have 2, 3, right? Because this is my r naught, or my r, sorry, and r is any point, unknown or known point on my line. So I'm not sure if it is, but we're going to do this. 2, 3 is equal to 1, 4 plus t 2, negative 3. What do I do from here, Mr. Wills? Well, I've actually got 2 equations and 1 unknown. So what I'm going to do is I'm going to solve for t in both equations, see if they're equal. So my first one, I'm going to take all my first coordinates. So this, this, and this. So what am I going to have here? I'm going to have 2 is equal to 1 plus 2t. Solve for this. So bring this guy over. I'm going to have 1 is equal to 2t, so t is equal to 1/2. Okay. The second one, what am I going to do? I'm going to take all my second coordinates. So this, this, and this, and I'm going to solve for t again. So I'm going to have 3 is equal to 4 plus, oops, so it should be minus 3t. Bring this over, so I'm going to get here negative 1. Negative 1 divided by negative 3 is going to be t is equal to 1 over 3. Are these two equal? These two are not equal. Therefore, 2, 3 is not on my line. They would be equal if the t values were equal, but they're pretty close, and you can see that 2, 3 is pretty close to being on my line, but it's not quite on there. All right, continuing on. Parametric equation of a line. So very much like vector equation of a line, it says here, find two coordinates. Find coordinates of 2 points that are on a line. So all I'll have to do is just choose two values of t. So here let's choose t is equal to, let's go even easier, t is equal to 0. So here I would have x would be equal to 3 plus 2 times 0. That is a 2, by the way. So x is equal to 3. And then y would be equal to negative 5 plus 4 times 0. So y is equal to negative 5. So my point would be then 3, negative 5. All right. Let's do another one. Let's do t is equal to 1. We'll do nice and easy ones. Let's try that again. T is equal to 1. So I'm going to have here x plus, or x equals, oh dear, x equals 3 plus 2 times 1. So here we can see x is equal to 5, and y is equal to negative 5 plus 4 times 1. So here we see y is equal to negative 1. So then I would have the point 5, negative 1. So my 2 points are here and here. All right. Now write a vector equation of the line. So a vector equation of the line, that's pretty easy. It's actually already right here for me. I've got my r naught. So these two are my r naught. And these two values, the two coefficients, are my m. So here vector equation would be xy is equal to 3, negative 5 plus t 2, 4. All right. Let's keep going here. Write a scalar equation of the line. All right, so scalar equation of a line is the equation, just to review, ax plus by plus c equals 0. So to do the scalar equation of the line, what I'm going to do here is I'm going to take both equations, so x equals 3 plus 2t, and I'm going to take y equals negative 5 plus 4t. What does this equation here, what does the scalar form not have? The scalar form does not have a t, so what I'm going to do is isolate for t in both and set them equal to each other and solve. So here I'm going to isolate for t, so I'm going to have here x minus 3, is equal to 2t. Divide everything by 2, so I'm going to get x over 2 minus 3 over 2 is equal to t. Over here I'm going to get y plus 5 equals 4t. So y over 4 plus 5 over 4 is equal to t. I've got my t isolated for, and now what I'm going to do is, since they're both equal to t, I'm going to take this guy and equate them. So I'm going to have x over 2 minus 3 over 2 equals y over 4 plus 5 over 4. Bring everything to one side. So x over 2 minus 3 over 2 minus y over 4 minus 5 over 4 equals 0. And then I'm going to find an LCD here. So an LCD between, what do you do once I have to do this side, but I'm going to find an LCD. My LCD here is 4, so multiply all this by 4. And I'm also going to multiply this by 4. So if I multiply this by 4, I get 2x minus 6 minus y minus 5 equals 0. And so my scalar equation would be 2x minus y minus 11 equals 0. There we go. So next one says this. It says, determine if L1 and L2 are parallel. So let me just go back to L1. L1 is this guy here. So it's going to be, oh, it's right here. Come on, Mr. Wills. So what I want to do is that for L1, I want to compare the direction vectors. So I'm going to call, the first one M1. This is for my L1 line. M1 is equal to 2, 4. So if they're parallel, the direction vectors would be the same. L2 would be my M2, and from here, so it's going to be here, 3, 12. And so what I want to know is, are these two, if they're parallel, they must be scalars of each other. So what I'm going to do is write them as ratios. So I'm going to take the first ones and write them as ratios. So here I'm going to have 2 over 3, and then I'm going to see if that's equal to the second set. The second set here are 4 over 12. Well, if I simplify this a bit, I'm going to have, well, still 2 over 3 is equal to 4 over 12 simplifies to 1 over 3. Are these equal? No way. So are they parallel? Therefore, L1 and L2 are not parallel. I think I'm going to end that first video here, and then we will do, for the last page, we'll do example 3.